Hi everyone, good morning, good afternoon, or good evening, wherever you are. So thank you for joining us on time. Before we begin, let me just give a couple more minutes for other participants to actually join us for today. In the meantime, just sit back and relax, and we will begin shortly in about 2 minutes time or so. Thank you. Hi everyone, hi Hardik, nice to see you again. And thank you for taking time for joining us on this special session that we have with Filecoin, who will go through some of the fundamentals of setting out IPFS, providing you with some experience on having some hands-on on IPFS, and also most importantly, introducing you to Web3 storage as well. So just let me quickly cover why we are here as usual. It's part of the Mercury Hackathon for those who are with us today and those who are watching it later on. Most importantly, the hackathon is really a space for us to innovate and redefine boundaries when it comes to NFTs. And it's really a combination of various technology, which includes IPFS, we have Web3 storage, we have estuary, we have NFT storage, and of course, the technologies and tools that the Decentrology team has provided as well for the Flow protocol as well. So for today, really thank you all for participating, and hopefully that we get an opportunity to learn more and for you to take a step closer to the project that you're building. So right now, let me just pass the time to Jorropo, who will be covering an introductory of what IPFS is to help you get set it up, and also to give you some hands-on experience on it as well. So Jorropo, your time, please.
Hi everyone. So I work at Protocol Labs, and I do developer advocate for IPFS and related technologies. And today I will just show you how to get started on IPFS. So the goal is you should be capable to use IPFS, and I'm also gonna show you Web3.storage, which you will see why later. It doesn't really matter right now. Can I share my? I cannot. Can you stop sharing your screen, please?
Sure.
Thanks. Yeah, now you should see my screen. So I have right here a new VM. Oh, a new VM that I just set up. It's empty. Well, it's empty. And I'm gonna walk you through setting up the most basic things. So the first thing I should show the documentation. It's the main reference to using IPFS. So if you have any doubt, that's the first thing you should look. The question is probably ask it there. So also, this is going to be the process on Linux. The process on Windows is mostly the same. What will change is just the location of some path. The ID remains the same. So how do we install IPFS? Well, first we need to get IPFS. To that, we have this.ipfs.io, which publish the related binaries to IPFS, and we will want to take go-ipfs. So take the version for your operating system and platform. I'm gonna just grab this one, and I'm gonna copy the link. Do I have? Yeah. And then you just download it. Okay, so I just downloaded IPFS. I can extract it. So basically, I've just downloaded an archive, like a zip file, but like it's Linux, so it's not a zip file. But anyway, it's the same. I've extracted it. If I list, I can see right here that I have IPFS. Oh, I just noticed it's a brand new VM. I don't have colors enabled. Yeah, exactly. I want colors. Yeah. Okay. Now, well, no. It doesn't want color. So there is an install script you can run. So yeah, just execute it. It basically tells us what it does. It moves IPFS to this location. What is also nice with this install script is that in case you were not running as a root user, it also changed the ownership of IPFS. So it's not if you have a file that everyone can execute, but is not owned by the root user, that's considered to be a security vulnerability. It's not a huge one, but still, it's better to do it. So now we have IPFS. I can just set up IPFS version. We have IPFS installed. Does anyone have a question at this point? Have I lost everyone? I'm gonna leave you like 5 more seconds. Well, good. I hope that means I'm doing well. So we have IPFS, and now we need to actually use it. So to do that, just type IPFS init, and it tells us it generated a new pair, a new key pair. This is going to be the identity of your node. It doesn't really matter that much. And so now we can try something. We can try this command, which is gonna show us some things. This is basically this is a small default file that is included with every IPFS install. This is just to show you some basic things. So we can look at the quick start, for example. Yeah, we have a lot of things. So the main issue right now is we are in what is called offline mode. I have IPFS on my system, but I don't have IPFS running. What I mean by that is like if I look on htop, I look at the list of processes. I don't have any IPFS processes. So that means that we are not running a node. Nobody's gonna be capable to contact us. So to fix that, we just need to run IPFS daemon. Yeah, if you see this, it doesn't really matter. Okay, I'm gonna fix it. So if you want to show it, it stops. Basically, this is on IPFS wants to, in case it had large amount of data, it wants to have big network buffers, so like 2 megabytes or so. And by default, the default Linux configuration doesn't allow that. And so you just type this command and you restart IPFS and it stops complaining. No, it stopped complaining. Yeah, good. The only small issue about that is that it will not persist across reboot. So I believe to fix that, you have no. You have an exact, you just dump it in that file. These commands. So this is the path we want to change. This is the option we want to change, and we sell it to 2,500,000. And we write it, but this is only for our current. This is only in memory. This only change the current configuration. If you want it to also keep this option with reboot, we just put this part of the line. So not the control C, just me removing the command, but this part of the line, we'll put it in that file. And so it ensures that the UDP part of IPFS have enough buffer to run correctly. So I can run the command. So this is gonna launch online mode, but the only issue is that it's not actually gonna it's gonna capture the whole part of my terminal. For now, I'm just gonna start a new terminal. We are gonna be able to see later how to fix that. So this is IPFS running. I can add a file. So I will create a small file. I want to call it, how can I call it? Hello, Mercury. I hope I spelled it right. I'm bad at spelling, so you know. The first command you should know is IPFS add. Also, when you learn a command, each command is actually just almost one-to-one an API endpoint. If I go to the IPFS documentation, API and CLI, HTTP API, we can see a command add. And so basically, when you learn a command minus HTTP formatting bullshit, you also learn the API. So that's quite neat. There are also wrappers for the API. If you don't want to deal directly with the HTTP, there is a Golang, JavaScript. There is a Python one. There are many ways to interact with the API. I'm just gonna add this file, and this gives me this. So this is the way we look at file on IPFS. This is called a CID, or a content identifier. And this is basically the hash of the file. If I copy this CID and I open cid.ipfs.io, this is the CID inspector. If I paste my CID, you can see a lot of details, and that's basically everything that is contained inside the CID. So we see that is base 58 Bitcoin. This is the way it is encoded. It doesn't really matter. However, we see something important. We see that it's SHA-2 to 56, 256 bits. We see the digest, which is the hash of the file. So what I mean is, like, I can take this file, take this CID. I can go on ipfs.io and paste the file here, and it should load, hopefully. If it's not gonna load, I'm gonna be sad. I believe there's an So what I'm interacting with right now are gateways. Gateways is just an IPFS node running that is serving requests on HTTP. So you can take, yeah, okay. It took a bit of a while, but I guess it's because my node is new. It loaded. So the gateway, we just give it a CID and it fetches the file. So what has happened in the background is that first the gateway searched through the DHT, which is a distributed hash table, which is our content routing network. It searched for a peer that hosts this file. It found my peer, and then it contacted my peer. So this peer, by the way, when I tell peer or node, it's the same thing. A node is a peer. Maybe you can say that peer or fruits, but I'm not convinced. So the gateway contacted my peer or my node and downloaded the file from it. The issue with using gateways is a security one. Basically, the fact that we have the hash inside the CID means that when we download a file, we don't only download it, we'll also hash it on our side, and we will check that the hash matches. So the hash is a fingerprint of the file. It's a mathematical fingerprint of the file. And if you change the file, any content inside that file, this hash also changes. So what is good is like if another node we're trying to scoop in some different part of the file. I mean, example, you are downloading IPFS on IPFS as an IPFS binary, and someone is actually sending you a malware. The hash will catch that. The hash will see, well, that's not the data I'm asking for, and it will just throw it away and ban the node for a little while. The issue is when you use a gateway, this hashing part is happening inside the gateway. It's not your browser that is doing it. I believe Brave has a mode to do it, maybe, but generally, it's best to run your own IPFS node. So that's IPFS working. We just has a file and we retrieve it from elsewhere. Does anyone have a question at this point? Or okay, I don't understand a reference to what. No, is that something else maybe? Ah, okay. So the main thing we should see maybe, we can see the IPFS Companion right now. So I'm gonna do something you don't really need to do, but I need. So I'm running right now in a remote VM. This is just an SSH command behind the back, and so you don't need to do that if you set up IPFS on your own machine. But what I need is basically bring IPFS to me. So right now, if I look at the node, it's listening for the API on localhost and 5001. I need to bring that port onto my machine. So basically, this command, this is just an SSH thing, which is gonna connect to my VM. And this is gonna take the port 5001 on my machine and connect it to the port localhost 5001 on the remote machine. And this is gonna allow me to use IPFS on my desktop while it's installed on my VM. So it's just that I already have an IPFS installation on my machine, and I didn't want it to just remove it for the example, so I started fresh. If you install on your machine, you don't need to do that. So what and so just bring IPFS onto my machine. We don't see it, but I could stat it maybe. But and so if I just look at the IPFS Companion, this is a neat extension that allows you to. You don't actually need it to use IPFS, but it's very useful. Oh, also, and now that I think about it, I will also need another port, which is 8080. So the main difference is that 5001 is an API. That means that you talk to the node, you request things from it. You actually basically have full access over the node. And 8080 is just the gateway. So the gateway will only give you file if you ask. So that's a safety thing. You don't want to browse all files, everything on IPFS over this, because maybe you will hit an HTML file that has some JavaScript that will ask your node to install a malware on your PC. Maybe that's very improbable, but like someone could do it. And basically, if you have the file on 8080, when the malware is going to ask, try to connect to 5001, the browser is basically going to say, hey, that's not the same domain, because the port don't match, and you are not allowed to do that. So that's the safety features from browsers. So yeah, I will just add it. I have it on Firefox. You have it on almost everywhere. I don't believe there is any browsers that don't support it. Like you have it on Brave, Chrome. Oh, maybe not Safari. I don't know about Safari, but like you have it on Brave, Chrome, and Firefox. And the install process is just you know how to install extension for your browsers. So if I and so that's the extension, and I can see the number of people I'm connected to. I can also I can also open this, and this is the web UI. So that's just a neat view of your node. I don't know how useful it is actually. I don't use it that much myself, but that's a neat thing you can do. And basically, the main point of having IPFS Companion running is that if I browse to an IPFS enabled website, example IPFS.io, what happened in the background is that IPFS Companion realized this is an IPFS enabled website. And so it basically moves me to IPFS. So we don't see the big thing, the big CID, sorry, the big thing right here that makes no sense, because it's using IPNS, which is one of the next thing we should see. One thing that I've probably gone over, how do you actually download something? So that's very simple. You just do IPFS get and then your IPFS file. So you can do slash IPFS slash, which is the theoretic best way to do it. But you can just paste your CID here. If I just grab my test CID, I now have a file name with this big thing. Okay, one thing you might notice is that when I edit this test.txt file, you can say maybe that the file got renamed to that. What I mean is like we lost the name and the extension. IPFS only remembers the content of the file and not the actual name. So how do we fix that? We basically cheat and put the file inside a directory. So I can do a directory that we don't care about the name, and I can just move test into it, and I can add this directory. Then we see we have two things. We first had added the file, and then we added the directory. And so I can go on. I will. Oh no, I can just have it anyway. It's fine. I can go on IPFS.io. This is so I've took the directory as the file, and inside I can open test.txt. And you might see something neat is that I've rose to a gateway, and IPFS Companion moved me to my node. So this might look a bit different. This is not. So what happened is like this CID is in my CID inspector here. Is in base 58 Bitcoin. And the issue with base 58 Bitcoin is that you have some characters that exist twice, both in lowercase and in uppercase mode. And the issue is that the DNS system only works in lowercase. So if we want to put a CID in the DNS, how it's done here, this is done for a safety reason inside the browsers. We basically need an all lowercase or all uppercase one. And this is basically converted to base 32. So it's the difference between CID. So this is a CID v0, basically because it starts with QM and if it starts with QM, it's a CID v0 and it's using base 58 Bitcoin. And CID v1 are more complicated. You can have a different type of encoding. So you can use hex, you can use base 36. Almost everyone just use base 32 because it's fast enough and it's good enough for everything. So where was that? Yeah, the directory. And so the directory, creating a directory each time you want to preserve the name is kind of dumb. We don't want to do that. So we have an option that is W. So if I look at the help page, we have pretty big help page. They're not perfect, but they're pretty good. We can see -W wrap with directory, wrap file in a directory object. And basically, if I take my test file out, so I have my test file that is out, and I can add it with wrap.directory. I could just use -W also. It's gonna create a directory for me, which is actually, I believe it's gonna have the same hash, no? Well, I'm not actually sure, but the file certainly has the same hash. And so this does not happen all the time because you can have a different metadata or file layout. But since we added the same data twice, with the same parameters, because that's just the default parameters, we produce the same CIDs in output. Does anyone have question at this point? Oh, I have Discord running. Well, no question. Feel free to ask question. If you have really any question, ask them. I'm here for this. Basically, what could I show next? So I guess the main point of I know one thing I could show. The profiles. So the IPFS config is located. I will install GQ. So okay. So by default, your IPFS storage is stored inside your home location at .ipfs. And so if I go here, I can see most of this. So most of those are we have folders that contain things. So blocks is where your data is actually stored. Data store, I believe that's metadata. And key store are where your private key are stored. So we have an important file for us, config. So the config file looks like this. It's a JSON file. It has you have many options. You don't need to know them all. What you probably should know is the profile. So profile. Yes, that's that. So IPFS config profile, and here you have a list of profile you can use. Basically, this is a part of the configuration that you can change easily. So, for example, let's assume you would like to use low power mode. Low power mode basically it make IPFS well lighter to run. Your node is not going to be part of the DHT anymore, which it doesn't change many things for you. That just for the health of the network, that's a bit bad. It would be better if anyone runs the DHT. But if you don't want to, it's fine. We are not at one node. One node is not going to change everything. So I can do that, and I believe there is a it's apply. I believe I can diff it. Yeah, I can dry run it. Dry run. And so if you do that, you can see what changes. So it's kind of packing the JSON in a dumb way. Like this is not very readable, but at least it shows what happened. So you have Autonet. Autonet is a service that helps other node figuring out what is their NAT type. So the NAT, if you don't know, a network address translator, I believe, or something like that. It's something on your router that creates the virtual network, your local network. So as you probably know, your computer is rarely directly on internet. Most of the time, you are hidden behind a NAT. And Autonet is a service that basically you contact a node, you ask him, hey, please, I would like to figure out what my NAT is. You disconnect to it, and then 5 seconds later, the node tries to connect you back. And if it can't, that probably means that your NAT is closed, and you will need to open it manually. Sadly, that I can't really show you, mainly because it changes on every internet service provider. I guess I could show you on OpenWRT, but I don't have any OpenWRT settings right now. So basically, yeah, we have also this. So the broad provider is by default on IPFS, kind of like Torn. When you download a file, you will also reshare it for some time. And this, I believe this disable it. I'm not actually sure of how. I believe setting it to 0 means that you may reshare it, but you may also just clean it right away. The HT client is the most important thing. Just even if you don't make everything lighter, if you have some issue running IPFS, just put the HT client. And if you run on anything mobile, like a laptop, just put the HT client. It's way easier to run. Basically, you're not going to be part of the routing, so you will not have 200 nodes connecting to you each second, or something like that. So that's the best. Everything like that is that doesn't really matter. It's just basically right now I have 600 and 900 as node target. You change that to 20 and 40. Your high water is a number at which you stop searching peers, other peers, and low water is a number at which you you start searching more peers. So basically, your peer count should always bounce between those two. And unless you run the DHT in DHT mode, you don't need that many peers. 40 peers is already plenty. And yeah, that's pretty much it. So I'm not gonna apply it, but something to know. Another thing about the NAT, if you have some issues not downloading file, so let's assume you add a file like I've done earlier and it doesn't work. That's probably because your NAT is closed. So what I mean by that is that other people cannot talk to you. So the way to use that, you just do an IPFS ID. IPFS ID gives just basically a lot of information about your node. And I just pipe it into GQ. GQ, you don't actually need it. You can run without. It's just ugly. And GQ is just a JSON reading tool for Bash, and so it makes it pretty. So what is important to check are the addresses, and to see that you have public addresses. So for example, if your node only has your local address, like this is the local address of my VM, and the localhost, and no public IPs, that basically mean you are not connectable on the internet, which is standard if your NAT is closed. If your NAT is closed, you might have UPnP, which is basically an automated protocol which allows your node to ask the router, hey, please open the NATs, but sometimes you just don't have UPnP and it doesn't work. So you will need to set it up and add the announces. I'm not going to do it here because I don't have the setup required to demonstrate it. And basically, see right here, that's a public IPv4. If you have any doubt about what public IP looks like, basically they don't look like private IPs. Public IP checker, maybe. Well, that's not really what I want. It's not giving me what I want, but that's a public IP. That's also a public IP, but on IPv6. Don't worry too much about IPv6. Not everyone has IPv6 yet, and so still IPv4 is way more important. So right now we have IPFS running, we can use it. However, we have a bit of an issue that it's a pain to use. Right now, IPFS is running only because I've not closed this terminal tab. If I want to close it, I will stop IPFS. IPFS is not running. If you don't run French, it's basically IPFS is offline, and so we need to do something about it. Oh, and I will also need to because the IPFS Companion is trying to connect to the node each time, and SSH is failing each time. So what we want to do is to set up a systemd service. So this is going to change a bit on depending on which thing you run on. If you don't really want to deal about that, what you can do is install the IPFS desktop. So one good thing about the IPFS desktop is like you install it mostly like any other application, and it will give you this thing you can expand. It allows you just to run the node in the background. So that's an easy way. However, I'm just going to use systemd because I believe that's what you should probably use. So to do that, I'm just gonna stake go IPFS git. I'm just gonna go on the GitHub and I'm gonna fetch the systemd file. So for those who don't know, I don't want that anymore. Okay, so systemd is just a way for Linux to manage files, and it's not files, daemons. Daemon is just something that runs in the background. So now if I go into Go IPFS, I don't remember where it is. I should find it like that. It's a system file, I believe. No. Service maybe. Yeah, is that. And so we have two different files. Or harden basically add extra restriction on your node. I'm gonna run the normal one. Okay. So what you will want to do, so you can read the comments. What you will want to do is just take this file and move it system right here in systemd system. So we install the service. However, we should read something. So this is only description, I believe. Where is the line I want to see? Exactly. User IPFS and group IPFS. So if I look at my user, how do you? Oh no, who am I? Okay, so this is the same thing. You can see I'm running as root. The issue, you ideally don't want to run IPFS as root, mainly because that's kind of dangerous. If IPFS has an issue like a vulnerabilities, someone is capable to take control of it. They basically have control over everything on your machine because root has control over everything on your machine. What we are going to do is create a different user for IPFS, and so that doesn't have any rights more than just running IPFS. And so what is gonna happen is that if someone take control over IPFS, they only take control over that IPFS user. Then they need to find other vulnerabilities to become root and gain the access on your machine. So that's just the way Linux services work. If you install other Linux services, they will either run as nobody, so nobody cannot do anything because it's nobody, or they will run as their own user. I don't believe IPFS supports running as nobody. Yeah, it doesn't. I'm fairly confident it doesn't. So again, this will just change on your setup. If you run on your workstation, you can just run IPFS as you. So what you will do is you will change. You will. Oh, it's asking me for password. Yeah, I don't know. I don't want password. Okay. So if you want to run as you can just take this file and IPFS. The user, you would change it to you, so I would change it to Hugo. But I'm not gonna do that because that's not what I'm doing. So I've added an IPFS user right now. I'm just gonna, because I don't want to lose my file, I'm gonna move my .ipfs file inside the IPFS user. I believe you actually move everything like this. So the difference is that this is going to move all the files inside IPFS, my .ipfs, into IPFS, the home IPFS. While if I do that, it's going to move .ipfs inside IPFS. Well, I want to unpack everything into IPFS. I can, and I believe now, if I do system social stars IPFS, we have an issue. So I messed up somewhere. What? Oh, I know why. Okay. I forgot to give them a right. So if I look at this, we see that the file are owned by root, but it's not root anymore that owns the file. So change owner IPFS recursive and everything in here. And I also want to change the group. And now I believe if I do I start IPFS, no, it doesn't. Why? I'm so bad at this. Why? It's executing rather quickly. Oh, I know why. I don't have any binary right here. If I do which slash IPFS, well, I don't have a. Okay, it's basically I've installed IPFS in local bin, and it wants it in user bin. I don't really know why. I'm just gonna change the file. So you could go about many ways to solve this. I guess the more Linuxy way would be to create a symlink, but I don't think that forces symlink. So the binary location is not correct. I'm confident. No, it doesn't. I should stop saying I'm confident it will start. Why? Why? Oh, I know. So you see, it's still taking the old path. So well, I've changed it here. Basically, Debian doesn't look at your service file all the time. So like right now, it has loaded my service file, and I need to update it. I believe you use system ctl daemon reload. Okay, so now it should have reloaded my service file, and hopefully we have a different error. If it doesn't work, I'm just gonna show you on my main machine because I I don't think it's very interesting to see me troubleshoot that. So okay, is that actually my IPFS path? Tell me it is. Version. Yeah, it is. Called exited fader. Well, I think I'm gonna move on. Just because yeah, it's just home permission denied. Okay, everything. I don't see why it has permission denied. It should. Everything here is owned by IPFS. Okay, so I'm just gonna remove everything here and start fresh. Maybe I've not properly moved my root installation to my IPFS one. No, it doesn't. Okay, well, just trust me, it works. I don't know why. I'm gonna show you on my main machine. So on my main machine, if I system gsystem slash IPFS. So this one is a file I've written myself, and as you can see, it's user one. So it's running as me at Hugo, and the working directory is my actual home. So it's running as my user, and you can see an init option, nice equal 8. In Linux, niceness is kind of like inverse of priority. So basically, the bigger your niceness, the less priority you have. So that basically means if I'm doing something else on my computer and I struggle, I don't have any CPU resources, IPFS is gonna slow down. It's first gonna watch YouTube or compile something, I don't know, something I do on my computer, and then it's gonna run IPFS. So IPFS doesn't bother you that much in case it spikes on CPU usage, which happens from time to time. And I can systemctl start IPFS. And it's asking for my password. Yeah. If I go here, yeah, and I have IPFS online. So that's how it should work. I don't really know why it doesn't, and I'm not feeling like it's worth digging it. This is probably something dumb I've done. I believe I know why. Maybe it expects a home location that is different that where it should be. No, the path is just, well, I'm not too sure why. Well, anyway, so it's not that important. what I want to show you last is Web3.storage. So right now, oops, I closed. So I'm just I need to init something new. So by the way, if you don't want to have the default bundled file, you can just add -- empty. And you have a shortage, which is -e. And if you want some profile, you can just make profile, and I'm gonna run the server mode. So server mode, disable local discovery, this kind of stuff. You can just do the dry run, as I showed you, to see what server mode is supposed to do. It's just generally considered to run it on server mode. Basically, since this is a server on just on storage provider, not storage provider, sorry, on that's just a server on somewhere, and I should have a public IP right here and not a LAN. Well, I do have a LAN, but okay, so that's my public IP. I don't see my public IP before, but basically, if you run on a public IP like this, it's not advised to use to run IPFS with local discovery enabled. So the goal of local discovery is, let's say my laptop wants to download something, it will first ask all the PC on my local network, hey, do you run IPFS? And I want this file. And my workstation is gonna respond, yeah, I run IPFS and I have this file. And so instead of downloading across the world, like halfway across the world, it's gonna download it from my workstation to my laptop, which is way faster. That's the goal of local discovery. But since this is a server, it doesn't have any LAN actually. Like it's alone in this net, in this LAN. I will run the thing. So I'm gonna run IPFS daemon. Now I want to show you is the main issue with IPFS, which is that IPFS doesn't host file. Again, it shares them. So if I add a file, I will create a new file. No, do I already have? Yeah. I will add no, not this one, because maybe it's cached somewhere. So I will create a new file, new.txt. This is a new file no one ever made. And I will add it. So I've added my file. The issue is if I shut down my node, so I just shut down my node, and I go here, and I try to fetch it from IPFS.io, IPFS. So it's gonna load. It's gonna take a while to load because the timeout is pretty huge, but it's never actually gonna load because just no one is hosting that file right now. As you can see, I have my cursor blinking. This is my bash, so the node is not running. No one has this file on the network, so it's not accessing. So the way to fix this is what we call pinning. Pinning is just a way to tell the node, hey, by the way, don't remove that file. You already have a pin list right here, and you can see those are the files that are pinned. You can add them with, so if you want to pin a new file, for example, if I want to pin IPFS, I'm gonna need to run in online mode for that, I believe. So I just started the daemon. For example, if I want to help IPFS, I can IPFS pin add. I'm gonna pin this.ipfs.io. Oh, I forgot to resolve. Resolve. Okay, so I'm gonna resolve this.ipfs.io. This is gonna give me a CID, and I'm gonna pin that PID. So this might take a bit of a while. I don't know how long it will take, but right now my node is downloading this.ipfs.io and adding it. Actually, this is too big of a file for an example. Just ipfs.io. It should be faster. And so yeah, exactly. And so I've added this file to my pin set. However, you should know something. I've not actually pinned IPFS.io. I've pinned the result of this command, which just resolve IPFS.io. And basically, if they update IPFS.io, I will still be on the old ping. So you will need a script that check it regularly or something like that if you want to pin IPFS.io. But my main thing is like, if now I do IPFS pin LF, I have way more files. Basically, one of them is the root of IPFS.io, and everything else, basically IPFS.io is a folder, and everything else is just files inside that folder, or also folders inside the folder. And so my node is currently hosting IPFS.io. The main difference between pinning and just downloading a file or resharing is like if I do IPFS, I can do IPFS GC, no? Repo GC. So this is gonna run the garbage collection, which is basically gonna remove a lot of blocks, as you can see. And this is files that I've downloaded, but I'm not using. And so it should just free some space. And if you have a file pin, it will not be freed. Pin files are kept forever. So ideally, we will want to pin that file, but somewhere else. And so the way we can do that is with web3.storage. Oh, sorry. Does anyone have a question? No. Okay. So here I have web3.storage. You basically go here. You are here. I'm gonna log in with GitHub because I'm lazy. So web3.storage is a service that is has been created by Protocol Labs, which is the company creating IPFS. So in that host your files, both on IPFS, which is sponsored by Protocol Labs, and on Filecoin. On Filecoin, it's not sponsored by Protocol Labs. It's using Filecoin Plus to pay. So basically, the way it's paying for you. Okay, so I should have gone over what I'm doing. I've got on my accounts. I've created a new API key. That's the one you just showed here. So I'm gonna remove them soon enough. So I have the API key here, and I can just copy it. I have the docs. Ideally, I should be able to. Do something with it. So the main issue I have with web3.storage, you cannot just give it a CID and it will pin it. You need to give it a car file. If I look at this, absolute car, retrieve a car exactly. And so a car file is kind of like a tar, but for IPFS. So it's just a list of blocks. Each block is a shard of a file. If your file is bigger than 256 kilobytes, it gets split into multiple shards, and so it can be downloaded from multiple people at the same time. And basically, I'm just gonna download it to IPFS. So the way this is not an issue on other services like nft.storage, but I'm gonna nft.storage, you can just give it a CID and it will pin it. I'm just gonna look at the command I've written previously. Okay, so this beast. Okay. So I'm basically gonna cheat. So I don't want to actually create a tar file, mainly because I don't know how to do it. No, I believe it's pretty easy. You just you have an export function somewhere. IPFS commons export, IPFS tag export. Okay, if that's really all that is. Okay, so that's really all there is. So I'm gonna create a big file, let's say. So I'm gonna copy from /dev /random. So let's just to create a random file, count equal, we want somewhat of a big file. This is gonna be half of a megabyte, which is not that big realistically, but and I'm gonna output it to test2. Okay, so I'm gonna add this file, test2 to my node. And I have here a big file, and I'm gonna upload this to web3.storage. So I will not need my ugly trick. I'm just gonna take this command. So Oh, I've wrongly copied. Okay. So this command, it's documenting. It is not that much. What is really happening is just that I have my huge API key that is here. So I should probably say this. Your API key is accessed on your Redefining account. Same for nft.storage. So you should not share it. I'm sharing it right now because just else I won't be explaining anything. But ideally, you should keep them private. It's better if you are the only one having access to your account. So it's loading. Copy the API key. And so the actual command is just basically curl, which is a tool to exporting data binary, because I want to upload the file in binary. I don't want curl to encode it in anywhere weird way. This is basically, it's kind of weird, but basically that's the data I want to send. The at right here is to say, hey, I don't want to upload data. Like if I wanted to upload blah, 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 for example, I would just type blah, blah, blah. But that's not what I want. What I want is to upload a file. So I put at right here. The at right here, right here. The at right here tells curl, I want to upload a file. And dash is, it's a convention in Linux to basically tell, I don't want to upload the file. I want to upload the standard input. And I'm just going to change both commands together. And so that's my API key. And what I'm going to do is I'm going to make IPFS tag export the CID of test2. No, I want to pipe it. So basically, I first run this command, then I pipe it, and piping it takes the output of IPFS tag export and send it to curl. And what curl will do is it will take the output of IPFS tag export and it will send it to api.storage.car. So if I do that, it's going to blip blip. I guess it's going to be, yeah, it's done. And we have here the CID, which we should check, hopefully. Oh, we have an issue. It's not the same one. Wait. Oh, no. No, I'm good. Here we can see it's just that I don't have color, so I'm kind of lost. But this is the CID of the test2 file. It's like it's sending by OFPP and OFPP. So that's perfect. That's the same CID. That's everything we want to check. If you mess something up, it's possible that Refi.storage will upload the file, but it will upload it as a different CID. This is just due to the way layout work. It's like when IPFS cuts the file, you can cut it in a different way. You can choose different points to cut it. You can choose different sizes. If you want to optimize the file for very random access, for example, you might want a smaller blocks. There is also the layout, which is you can have files that are optimized to be straight. If I can show you the option right here. So you don't need to remember them. It's just like I can add a file with two different rules. So you have dash trickle, for example. We use a trickle tag format for tag generation. Basically, if you enable this option, the file will be only a straight line of blocks, almost. And a straight line of blocks is way slower to download, but it takes less space. It has less overhead. Or you can also do the default option, which is just all direction equally, and that is very fast in theory. In practice, IPFS is not that fast, but that's just an issue with Go IPFS, which is not very optimized yet. And the other option, you can add experimental stuff, for example, inline. If you have a file that is only 5 bytes, let's say, if you just want to add hello, it would be kind of dumb to create a complete block just for that file, because a complete block is one more step to downloading that file. So if you enable inline, instead of storing the file as a proper file, it's just going to take the file and stick it into the directory. That's a pretty nice option. You probably want it. And the other option is a chunker. And basically, so you can have a Rabin, which is gonna it's gonna try to balance stuff, but like not ideally. Size always just perfectly balanced. It's just a division, and it puts a remainder somewhere. And bus hash is going to try to look for same place inside your file. So it's kind of doing compression on your file. I don't run bush. I just run the default size because that's mostly fine. And so if you change those options, which Webflow.storage actually change those options, they change the size, and I believe they do inlining, something like that. And if you change those options, IPFS, the CID are going to be different. Not because the actual file is different, but the CID is not only the hash of the file, it's the hash of everything inside IPFS. So if you change this option, the hash is going to change because the layout of your file inside IPFS is going to change. I can show you this with my IPFS tester 2. So if I add it to the default, it's looking like this. But if I change the chunker to a smaller size, let's say 100K. Why? I believe it's dash. Yeah, it's like this. You can see I have a different CID. This is just because I've changed the layout of the file. So that's an important thing to note. And that's why I'm using this nonsense command. Basically, by doing this, since I already provide blocks to Web3.storage, it's not gonna try to change the file. It's just gonna take what I give him and host it. Okay, so that's what I wanted to. So right now, if I stop my daemon after all of that, why did I go through all that troubles? I have my daemon stopped, but if I go onto Web3.storage, I should have the file right here. It's loading, hopefully. Okay, I have my CID right here. Okay, it's queuing. When this will be finished, like it takes a few minutes, the file will just they will store my file for me. So for example, this is an audio file I was doing. I can open it. And as you can see, my node is not running because I've shut it down for the example. So like it doesn't show up here. So none of my nodes are hosting that file, but I'm still capable to open it just because Web3.storage is hosting it for me. And another thing Web3.storage does is it stores it on Filecoin, which Filecoin is a blockchain which allows for storage providers to host your files. So this is a storage provider, and they gave it a file. The storage provider is hosting it for me. So the main issue of Filecoin is like it costs money. Even if that's not that big, that's still a price you have to pay. And running a Filecoin node requires syncing the complete network. So you have a terabyte of chain, I believe, to download. This is not the case with IPFS. So that's why ideally you store your file on both. Do we have any question? I believe I'm mostly finished. We have a bit more time to do Q&A. Or maybe I can show you something. For example, I can show you how you can do an Ethereum NFT with this. I have an example I can show you. So I mean, how to get from an NFT to how to add your IPFS files into an NFT. Okay, don't we have any other question maybe? Before I show you how to make an NFT, which would be nice because there's yeah. Okay, no question. So for the NFT, we just need to get first an NFT contract, which is less. It's not really IPFS related. So I'm gonna use Ethereum just because I have a contract already ready. So that's really just for that. So I have a contract, so I'm not gonna spend time writing one, which takes. I could. You have an NFT contract you can use that already exists, but I have my own right here. So the way you connect an NFT to IPFS, you create a contract, which is some piece of code that run on the blockchain. So this is the Ethereum blockchain, just for example, but maybe a blockchain is going to do something different, but most blockchain follows the same global ID. So on Ethereum, to have an NFT linked with IPFS, you implement the function URI function URI. So basically, you take a token ID. So in Ethereum, you have one contract that is kind of like one collection, And each token ID inside that contract is a piece inside the collection. And so each token ID is going to be its own NFT. And we just return the URI, a distinct uniform resource identifier for a given asset. So our goal, the goal of this function, is just I give it 10, let's say, and it's gonna write something like this. It's gonna do IPFS base, which you are gonna see in 1 second what this is, plus str of 10 plus .json. That's basically all the code that there is. And actually, I'm just gonna up token ID right here. So all of this code might seem impressive. It's really not. It's just that Solidity doesn't have a way to convert numbers into into strings. Sorry. So I'm basically doing it manually. So the way you do that, you first get the length of your number, which is simple. You just divide it by 10 until it's 0. What happens then is like so this might look like some trickery magic. It's really not. So this first part, like the UNC8 right here, this is basically just this is taking the reminders. So this is taking the first digit. It's basically like a mod 10 operation, which yeah. So it's just the mod 10 operation, which is kind of convoluted because do you have mod? I'm not sure why I'm doing that way. But anyway, that's just taking the digit of your token ID. I'm adding 48 because I want a character out of that. What I mean by that is like I don't want to get from a binary number to the number three, for example, like the number actually written in decimal. I want it written in a string, and so basically 48 is in ASCII. If I open Python 3 and I take the ordi, you can see it's 48. And all numbers in ASCII, or just take one cell from 48. So to get the string from it, you just add 48. And I'm adding it inside this buffer, which like returns it. You can probably find similar code other online. And I go through all of this just to, this is the same code in Python. Really, it's just taking IPFS base IDs thing. And so the way I will do this, I would first need an NFT collection. So I have one on my desktop, I believe. No, I mean, yeah, NFT, exactly. So this is the alphabet. I've made this for another thing, but like, well, it's what I have on hand. So I can just open this in like shuttle. And so this is the alphabet. And you can see that I've numbered them from 0 to 25. That's just useful because then in my contract, I can just, to know if a token ID is valid, well, I just know it's the alphabet. So I have a function, a modifier actually, like my piece of code, just check, where okay, exactly. It just takes that the token ID is below the total supply, and the total supply should be 26. Because I have 26, you have 26 letters in the alphabet. So the way I'm going to do that, so I'm going to add this to IPFS. So I could just IPFS add NFT, but I don't actually need, because the file I've uploaded earlier, right here, is already this file, and it's already pinned. So I can just use that. And so the way I would go about that, well, I'm not sure what's my password. I'm going to stop the screen sharing for a moment. I will be entering my password. I actually, okay. I actually don't need my password. Okay, I can just use a simulator. So inside Solidity, right here, I will use a JavaScript VM. So it will be running Remix, the editor, I mean, will be running the transaction. They will not actually run on chain. At first, I wanted to run them on the testnet, but like it doesn't really matter. So I prepare my contracts. I just have to pass the constructors arguments. So the total supply is 26 because I have 26 letters. The name is going to be alphabet because why not? And it's gonna the symbol is going to be ABC, and the IPFS base is here where this gets a bit interesting. So I take my CID, and the way I've written this, I want it to be as lazy as possible. So the IPFS base is all of this. So it's IPFS column dot slash slash. I know it's really tiny, but you cannot. If I try to resize remix, it freaks out. So I will just send in. So that's basically what I'm sending to my contract. I'm giving it the thing, and so it deployed successfully. Now, if I look at my token URI function right here, I can take the 15 letters, for example, and it's going to return me this. So IPFS.// my CID slash 15.json. So this is what that is returned. If I open this, so this is basically 15. Where is 15? Okay, right here, 15.json. It's taking a bit to load. So the main issue with using Webflow storage is that it's not the fastest. You can get much better performance by running your own node, but like they also have way more things to host than you. So I'm just gonna start my own node too. I believe it will be started soon. Yeah, exactly, started, and I can fetch the file just from my own node. And like it's instant because what is neat is like since I have the file inside my IPFS cache, I don't actually have to fetch it from anywhere. I can just load it from my cache. And so you can see the 15. So that's just the way NFTs are made inside Ethereum is that you have a JSON file, which is a metadata file. So you can see the letter P. You might say, wait, that's 15, that's 16. That's because this is indexed from 1 and this is indexed from 0 because that's the way human count and that's the way computer counts. It's not that important. And you can see we have an image, which is another IPFS link. The way I've built this, it's actually a link to, I have here an image folder, and inside that image folder, it's all the 15 thing. It's linked. And basically, what OpenSea will do, for example, is that it will take the token URI, it will fetch it from here, it will go on IPFS. On IPFS, it will find this file. This file tells it, hey, move here. Then it's going to move here. And from here, it's going to land on this file. And that's just the way it is. So you just put the CID inside the contract. It's like the most simple thing. Does anyone have any question? I believe we have 5 more minutes. And I kind of want to show you that. So the main issue of IPFS, everything I've showed you right now, the CID, you cannot change them. Because it's a file, if you change it's a hash, sorry. Because it's the hash of the file, if you change the file, you must also change the CID because the computed hash will be different. So if you want to update this, you can't. But I'm going to show you how to do it anyway. So the tips is not to share CIDs. You cannot update a CID, never. A CID is immutable. So what you can do is use IPNS. So we have IPFS name. And you have 3 ways to use IPNS right now, and maybe more in the future. So you have this one, which like it uses the node. I'm going to start my node backup. It's going to use your node to actually publish the file. So this one is free, but like it's storing it in the DHT, which is not the fastest thing. I believe this is going to take a long while. That's not even very reliable. So I don't really think you should use that. The two other options are DNS and ENS. So if I look at IPFS, what can I look? I can look at IPFS. Yeah, I know what I can do. I can do host by txt. So we have something that is called DNS link. That's basically just txt DNS record. So if I do that, why? What have I done wrong? Oh, I know why. Just because I'm using host, I should be using dig. It's like the syntax is different. Dig. I believe it's just like this. Yeah, it's like this. So as you can see, if I request DNS link on this, you have a record that is called DNS link equal and /IPNS /website.ipfs.io. What this tell me is basically repeat the same process. So I resolve DNS link at website.ipfs.io, and here I obtain another DNS link. This time it's not IPNS, it's IPFS. You can see the difference right here. And that's the CID. And that's the CID I will get if I do IPFS name result. Oh, no, my bad. IPFS name result on IPFS.io. And you can see the same CID because we basically just did the manual way. This is pretty good. So the DNS link is also what is used for the, see, I have a node running right now. If I go on IPFS.io, it moved me to IPFS. And the reason it moved me to IPFS is because this DNS link record exists. So every time you browse a website, the IPFS companion is going to try to load DNS link from it. And if it is that there is a DNS link record, then it's going to move you to IPFS. So that's a very useful thing. I cannot really show you how to actually do that, mainly because like you just go on your host providers. If you use your own DNS, well, you probably know how to do that, but like just add a TXT record that is DNS link equal /IPFS/CID. You will automatically move people to your site. And another thing you can use is my voice. I'm losing my voice. Is ENS. So okay, so that's that. Can I look for something like? No, I don't have one. I'm gonna take a random project that I know have an ENS record, and basically you can use. You can see that inside of so this is a Ethereum naming system. Again, sorry to be so Ethereum centric, but that's just what I'm used to. And like it's the quickest thing for me to browse. And you can see that you have a record for IPNS, and here they put an IPNS to their website, and you can mix match them. So basically, either you can put a CID here, which is the most like decentralized thing. The DHT is also pretty decentralized, but the DHT option doesn't work as well. So this returns a domain, and then we will need to do the same dig thing. So I can dig plus txt on DNS link. Why? Because there's no plus maybe. Yeah. You can see here it's a hash. So you can mix match the different providers. It works fine. It just keeps recursing until it works. And so that's the way IPNS works. So this allows you to change things, to change the actual CID you point to. Does anyone have any question? Because that's really the end, I believe. I don't have anything more to show you. Just grab your CIDs and fetch stuff.
Yeah, Jorropo, I think you've covered really well with a lot of things. So yeah, I really thank you for for spending the time to help us cover all the introductory portion of setting up IPFS and also Web3 storage as well. And I believe for all who have been joining us or will be watching this later on, will be able to access the necessary documents. And of course, for those who are at Mercury Hackathon, please feel free to drop a question in our Slack channel as well to either the mentor session or any of the Filecoin help desk if you have any specific questions with regards to setting up of IPFS, or if you are working on any Filecoin projects, and if you meet any difficulties and all, do reach out to Jorropo as well. He's also reachable via the Slack channel for Mercury Hackathon as well. So just a quick cover of the event schedule that's upcoming for.
Sorry, can I catch you 1 second? I just
Yes.
want to repeat something. In
Sure.
case you have, in case you need information, again, I said it at the start, but like I believe it's important. Docs.ipfs.io. Go check it. It's pretty good. You can also ask questions. But ideally, the docs maybe respond faster. That's all I wanted to say. Docs.ipfs.io. Check it out. It's pretty good.
All right, thanks,
Thanks.
Jorropo. So for those, just a reminder to check out at docs.ipfs.io. That also will be somewhere that you can check on the resources as well. And a quick recap on the upcoming event schedule that's upcoming for the rest of the few weeks. One will be the networking activity, which will be happening this Saturday. So for those who have not yet registered, please head on to the Slack channel or the EDM that's actually sent to your mailbox to actually register for the networking session. And the meeting link will be sent to you closer to date as well. We do have a pitching workshop that's upcoming the following week as well, where Harish will bring you through how you can prepare your pitch, which is part of the submission for your project. And last but not least, the submission closes on the 31st of October. All information from today or anything that's regard to the hackathon can be found in your participants guide, as mentioned previously and many of times, that you can access through the mailbox once you have actually registered, or you can simply head on to any links that you can see on the Slack channel as well. Lastly, if you have any problems that you face and you need some help, you can reach out to myself, Justin, on Slack or email, or you can reach out to Harish similarly via Slack and email as well. So thank you all for the time today, and please have a good day ahead. Thank you.